In section 2 of chapter 5, we look at still discrete random variables, but we're going to focus on how can we find the mean, the variance, and the standard deviation, and also an expected value for a discrete random variable. So still looking at a probability distribution. If we kind of get in the frame of mind that in the previous unit, we were able to find the mean and the variance and the standard deviation from a grouped frequency distribution. So more or less, we still have a distribution of some sort. In this case, it's a probability distribution, and we want to be able to find and interpret the mean or the average value, find and interpret the standard deviation, which is based on the variance. So we're going to discuss that in this video. You will have some new formulas. So the mean of a probability distribution, indicated by the mu, which is a population mean, is the sum of each x value times its respective probability. And so remember, the x is the event in that discrete probability distribution, and p of x is the probability that this outcome occurs. And then the formula for variance and standard deviation, well, if you notice, to find the variance, it's similar to this formula, except we have x squared times the probability. But now we have to make sure before we had to be attentive to finding the mean correctly, but now the value for the variance is dependent upon the value of the mean. So we want to make sure that we are very careful with our calculation so that we don't, if this value is off, that means the calculation for variance will also be off. And so will standard deviation, because the standard deviation is just the square root of the variance. And then we'll talk about an expectation more later in this lecture video. But the expectation is the same as the mean value. So we'll get some practice calculating these three values, and then we'll calculate what an expectation is. So for this particular example, we have the discrete probability distribution here based on the problem. So it's about traffic accidents. The county highway department recorded the following probabilities for the number of accidents per day on a certain freeway. For 1 month, the number of accidents per day and their corresponding probabilities are shown. Find the mean, variance, and standard deviation. So this would be a discrete random variable, discrete because it takes on a finite number, and then these are the probabilities of those occurrences. So the likeliness that they had no accidents on a given day was 40%. The likeliness they had one accident on a given day was 20%, and so on. So we want to be able to calculate the mean, the variance, and the standard deviation. And to find the mean, if we think about our formula, it's the sum of this column here, each x value times the probability of x. So we multiply those values together. 0 times 0.4 is 0, 1 times 0.2, 0.2, and we do that for all the values in this column. And once we get those particular values, the average comes from the sum of the products of each discrete random variable value and its respective probability. So when we add those values together, we end up getting 1.3, and that represents a number of accidents. So when we interpret this value, we know that the mean represents an average, but for this particular case, we have to think about what type of average is this reflecting. Yes, it's the average number of accidents. However, we have to think about on a very large scale here. So for when we collect data for these traffic accidents, we have to keep in mind that the data presented here in this table is only for 1 month. So it's looking at the number of accidents for 1 month. How many times did no accidents occur? How many times did one accident occur? Up to how many times did 4 accidents occur in that 1 month? So on average, if we take many months and we look at the data for many months, on average, there are approximately 1.3 accidents per day for any given month that's been selected. So that's kind of how we interpret that particular value. Now, in order for us to find the variance and the standard deviation, the next column will be necessary, because the formula is the discrete random variable squared times the probability. So that's this information, minus the average squared. And so we need this value first before we can find the variance, and then we have to calculate the variance before we can calculate standard deviation. So if I want to find the variance, then I'm going to have to figure out the values in this column. So I'm showing you the process here rather quickly. But we have the x, which is the number of accidents squared times the probability, 0. So these are what those values are coming from, this process here. And then this is the formula that I want to utilize in order to calculate that. So if I add the green numbers together from the very last column, that will give me just the sum of x squared times p of x. And then I want to also subtract out the average that we found out previously. So that means my variance is 1.81, and this number is always a positive value. If in your calculation you somehow got a negative value, then you want to recheck that calculation, because if we're squaring a number, that means the result should be a positive value, because a number times itself, whether it's -2 times -2 is positive 4. 2 times 2 is positive 4. So this value for variance is always positive. And then to get the standard deviation, we take the square root. So the standard deviation is 1.35 accidents. And again, how we interpret that, remember from the previous unit, a standard deviation is a measure of variance, or it's a measure of variability, or a measure of spread. So we look at the tendency for the values to have some type of variation, or how they fluctuate. So when we look at, how we can we interpret that, again, on average, the number of accidents, they typically vary by about 1.3 from the mean of, they vary by 1.35 from the mean of 1.3 accidents per day. So if we were able to look at the data for the entire month, then on any given day, the number of accidents that happened on that particular day tends to vary by 1.3 from the average. I'm not sure why I keep saying 1.3. It tends to vary from 1.35 from the average of 1.3 accidents a day. So, and we look at different randomly selected months. That's what the standard deviation tells us. It's just a measure of spread from each value in comparison to the average value. So let's look at another example and kind of see how we can calculate that. So for this particular problem, it says daily newspapers. A survey was taken of the number of daily newspapers a person reads per day. Find the mean, variance, and standard deviation of the distribution. So when we look at our distribution here, that shouldn't say, there we go, it should say newspapers. There we go. So newspapers, and again, it's discrete because it's a finite number, it's countable, and it's a discrete probability distribution, because we know that and I didn't say this on the last one, but if we were to add these values together, we should get 1, and then each value is between 0 and 1. So if I want to find the average number of newspapers read per day, then we look at the formula for average, which is the sum of this column here. So we take each x value times the probability, and here I really didn't show that, but 1 times 0.35 is 0.35, 2 times 0.20 is 0.40, and 3 times 0.03 is 0.09. Now if I add those values together, it will give me the average value. And to interpret that, for many surveys, right, because this data was collected from a survey. So if we conduct many surveys, then on average, the number of newspapers read daily is about 0.83. That's what that 0.83 represents. So if we kind of reproduce these results and we just take different samples from many surveys, then we would expect on average the number of newspapers read to be 0.84. And so we need to make sure that that result is accurate, because that's going to help us find the variance and the standard deviation. Now our variance again comes from the last column, so we have the x squared, these values squared, times the respective probability. So and then minus the mean. So when we find those values, and again I didn't show that here, but 2 squared is 4, 4 times 0.20 is 0.80, 3 squared is 9. 9 times 0.03 is 0.27. So when I add those values together, it will give me this calculation. So 1.39, add these together, minus the average squared, and that'll give me the variance. So this is my variance. I need that value to find the standard deviation, which is the square root of that, so 0.83 newspapers. And then when we interpret that result, again, it's the measure of spread. So when we look at raw data for many of the surveys collected, then the typical spread from each one of these values for the newspapers compared to the average value of newspapers is about 0.83. So on average, the daily number of newspapers read typically vary by about 0.83 from the mean of 0.84. So it's just kind of tells us the distance that a certain value on average is from the mean value. In this case, it's about newspapers. So that's how we would calculate the mean, the variance, and the standard deviation for a discrete probability distribution, and then how we also interpret the mean and the standard deviation. So more or less the way in which we calculated the mean, variance, and standard deviation in chapter 3 for a grouped frequency distribution in unit 2, we have a similar process with this table model, how I kind of organize the data, but the formula is different. The interpretation is the same as we looked at before, how we interpret the mean and the standard deviation. Now, the next thing that we'll look at is an expectation, right? The expectation is more or less an expected value, and we have to build the probability distribution ourselves, and which is why in the first lecture video for section 1, I went over that problem so we can kind of just see in action how we would construct a discrete probability distribution, so that when we constructed one in section 5.2, it wouldn't be entirely brand new. So for this particular problem, it says a lottery offers one prize, $1,000 prize, one $500 prize, and 5 $100 prizes. 1,000 tickets are sold at $3 each. Find the expectation or the expected value if a person buys one ticket. So more or less what we need to determine is, in this situation, what should X represent, and then what's the probability of X, so we can find the expected value, which is the X value times its probability. So in this case, since we want to find the expectation if a person buys a ticket, then our value of X is going to basically represent kind of like not really profit, but like a net gain, more or less. So if you buy a lottery ticket at $3 each and you win a prize, what is your net gain that you get from that prize? So for instance, if I bought for instance, we have, so those are our net gain. So we have 3 different types of prizes that we could win, right? And those prizes come with a dollar amount. So there's one prize that could be won for $1,000. There's also one prize that could be won for $500, and there's 5 prizes that could be won at $100. So we have to kind of consider, if they're selling 1,000 tickets, then 7 of those tickets are reserved for people who actually win something. That means 993 tickets are reserved for the losers, or someone who wins no money. So now that we kind of have in mind our prize amount, now we think about, well, how much money do we really walk away with? So I bought one ticket, or we buy a ticket, and if I win that grand prize of $1,000, technically the net amount that I walked away with was $997. Because I spent $3 and they gave me $1,000 back for my winnings. Similarly, if we bought the ticket that won $500, then we really walk away with $497. For the 5 tickets, if I get one of the 5 tickets that were $100, then I walked away with $97. And if I get nothing, if I won nothing, if I bought one of the lucky losing 993 tickets, that means I walked away with negative $3 because I no longer have that money. So this is what X represents here. Our net, our possible, or you could say winnings, our net winnings, or the money we gained from buying a single ticket. And then the probability of each event, well, there's 1,000 tickets, and so only one ticket can win $1,000, or only one ticket can ensure I walk away with $997. That would be 1 in 1,000. Again, only one ticket represents a prize amount of $500. So 1 in 1,000. 5 tickets are for winnings of $100, so that'd be 5 out of 1,000. And then 993 tickets, you don't win anything. So that information, these last two columns, the column in black and the column in blue, would represent what information I would put here in order so I can find the expectation or the expected value if a person bought a single ticket. So we have that information that we can put in our table now. Generally, the values are written from least to greatest. So I'm going to speed that up a little bit. And now we can look at, well, if I want to find the expected value, which is the discrete random variable, so these values times the probability, so -3 times this value, -2.979, 97 times this value, and this was 5 out of 1,000, so I'll reduce that fraction. And once we have the values, we can find the expectation, which is the same formula as the mean, right? It's the sum of the probability times its discrete random variable. So if we add those together, we get -1 or -$1. So the expectation for one ticket is -$1. And if, let's say, I were to buy 5 tickets, it would be an expectation of -$5, right? It's just 5 times that. And so what this essentially tells us is this is the expected amount that for many tickets purchased, this is the expected amount that someone would walk away with, -$1, based on the distribution of how the prizes are being allocated. And in your homework, you'll have a problem similar to this, where it talks about winning a lottery prize for you to kind of fill out, make a table yourself. So it'll be a similar situation, except it may give you, instead of 1, 1 and 5, it could be 2, 1 and 3. It just kind of changes on the value. So this would be more or less how you would set yours up. And then let's look at another problem, kind of similar. So a 35-year-old woman purchases a $100,000 term life insurance policy for an annual payment of $360 based on the period life table for the U.S. government. The probability that she will survive the year is 0.999057. Find the expected value of the policy for the insurance company. So for that particular year, what's the expected value or the expectation of that policy for the insurance company? More or less it's the same process. We have to kind of think about how our table might look. So we know that this is the probability that the woman survived. So the probability that she does not survive or that she dies is 1 minus that, right? It's the complement. And what we want to figure out is more or less the gain for the insurance company. So like we talked about the gain for winning the lottery for the tickets based on how much you paid versus how much you won, this would be similar. I'll look at what is the insurance company gaining in that year based on the probability of whether she lives or dies. So if she does not survive, that means for the year she would have paid her $360 and the insurance company would have paid out $100,000. So their gain would be negative $99,640. However, if she survived that year, then the probability of her surviving is 0.999057, and the insurance would have gained the entire $360. So when we look at the expected value, well, the expected value is just the mean, which is the discrete random variable x times its probability. We multiply those values together. and then we add those two numbers together to get the expectation or the expected value. So in this case, the expected value for the insurance policy that the company will receive is $256.70. So that's the expected value of the insurance policy.